Okay, this is our last IXL consumer math topic. I know these have gotten a little bit tedious at times, but it is useful stuff to know how to do in life and not just inside a math class. Before we start, let's just remember, I'm sure everyone knows how to do this right here. And if you agree with me that you know how to do this right here, you also know how to do the example problems I'm about to show you. So if I asked you to figure out 12 equals 4 times some number, you'd probably be able to figure it out in your head, but when we studied equation solving, we learned that there's a very systematic approach that we can always take. If we're trying to solve this equation, what we want to get x alone on one side or the other of this equation, and so I have to undo whatever math was done to it in the first place. So we can tell what's happening here was that 4 was multiplied times x. And so how do I undo that? Well, that's pretty easy. Just going to divide by 4 on both sides. 4 divided by 4 is 1. 1 times x is x. 12 divided by 4, it's a division problem. 12 divided by 4 is just 3. So one-step equation solved by simply doing one step, which is division. And that's exactly the math we're going to be doing as we work on these last IXL problems working with percentages. In this case, we are being asked to find an original price given the sale price. So we're given what the percentage discount is, or it could be an increase, but I think in all of these it's discounts. And we're also told what happened after the discount was taken. And we're being asked what is the original price. So Lucy wants to buy a carousel horse. She can get it on sale for $312, and that's because it's 25% off. So what was the original price? And it might not seem like we would care, but there are certain situations in which we would still be paying tax, let's say, or something on the original price. So we might need to be able to figure that out. The good thing about this is if 25% was being taken away from the original price, that means that the new price is 75%. Because if I take the regular original price of 100%, whatever that was, take away 25%, that sale price represents 75% of the original. So if we decide to let the original price be, let's call it the variable x, that's what we're trying to figure out, we could actually set up a one-step, very simple equation here. We could say that the price of $312, since it's 75% of the original price, that means it's 75% of x, our variable. So remember from before, we're not going to use percentages, we're using actual decimal representations here. So this is really 0.75 of, or times, x. And this approach right here is what we're going to take every single time. We're just going to look at the original price and say, well, that's the same as 75% in this case of the original price. And then that can be shown by this one-step equation, which I'm going to solve by dividing, just like I did on that opening screen. If I want to get x by itself, the way to do that is to divide both sides. This cancels out, giving me x. So the original price, x, is found by doing this calculation right here. 312 divided by 0.75. And I do that on the calculator, and when I do, I get an original price of $416. That makes sense because the sale price should be lower than the actual original price. And what should also be true, if I just wanted to make sure I did this right, is it true that 312 divided by 416, is that the same as 0.75? It should be. And when I type it into my calculator to confirm that, I find that that is really true. Okay, same situation. We had a sale, 50% off. We don't know the original price, so let's just call that the thing we're trying to find, x, which we're going to set up a simple equation for. And the sale price, after the discount was taken, was $79. So again, the original price, whatever it was 100%. When I took away 50%, I got the sale price, which was basically 50% of the original. Okay, so just like before, these are all percentages. You can change them to decimals in a minute, but In our case, that means this sale price of $79 is the same thing as 0.5, which is the decimal expression for 50% of the original price, which is our variable here. Just as before, divide by 0.5. Some of you who are thinking this through using your number sense, sorry for that size of that decimal there, kind of big, are thinking, well, wait a minute, if I'm going to divide it by 0.5, that's the same as multiplying by 2, and that's technically true. So if I do this calculation right here, I get that the original price, notice it doesn't really matter which side of the equal sign I'm going to put the x on. I can switch it to the left or the right anytime I want, doesn't matter. So the original price, given that the sale price was $79 and that was only half of the original price was $158. Which is basically this number doubled, which makes sense given the fact that half was taken away, so it started off as twice as much as that. Okay, now we're taking 75% off. Wow, this is a pretty big discount here. You're going to be surprised at what the original price was, and I know I was when I did the calculation a minute ago. The original price is what we don't know, but we do know that what we paid was only 25% of the original, because they took 75% off. That's a huge discount, which means that 25%, $209 is only 25%. It's basically only a fourth of what the original price was. So that original price, the sale price of $209 is the same thing as the decimal version of 25%, which is 0.25, of or times the original price. So you can start to see this is fairly repetitive here. We're just doing the same thing each time. Divide by 25, divide by 0.25. Some of you may have noticed that another way to do this would be to multiply that 209 by 4. If this is only a fourth of the real thing, or the original thing, I could just multiply by 4. In any case, I get a pretty big number because, taking 75% off is taking most of the price off. And so when I put it back to where it started, it's $836. Which, by the way, is the same thing as 209 times 4. All right, last one. 10% off is pretty easy. If I took 10% off from 100%, that means the sale price is 90%. So here we are, we're trying to find the original price, so we're going to call that our variable x. And we know that this $36 is 90% of the original. $36 is 90%. Notice I'm using the decimal here. The 0 is unnecessary, but I like to include it because when I say 90%, when I write 0.90, that seems to reinforce that I'm talking about 90%. Although that 0 is not necessary. It's not wrong, it's just not necessary. Times x. So again, just as we've done, we divide by 0.9, divide by 0.9, and it turns out that when I do this, this cancels out, and the original price was $40. Think about what's 10% of 40. Well, that would be 4. Take $4 away from 40, you get the price of 36. So a couple different ways to think about some of these problems. Hope you don't get too hung up. Please don't be shy if you need help.